Assalamualaikum warahmatullahi wabarakatuh. In today's video, our group will be presenting about one topic in application of differentiation, which is related rates. Now, let's meet three of our amazing group members. First, Muhammad Iman Syahmi bin Muhammad Safarin, and then Muhammad Haris bin Effandi, and then one Muhammad Haris bin one Muhammad Din. Okay, first, we are really grateful because we managed to complete this video presentation within the time given by our lecturer, Madam Rohayati binti Mat Ripin. This assignment is impossible to be done without the amazing cooperation and effort of our group members, which is me, Haris, and one Haris. We also sincerely thank our lecturer of MAT 183, which is Madam Rohayati, for the guidance and willingness to help us in what we are lacking when completing this assignment, and surely for teaching us this course. Last but not least, we would like to express our gratitude to our family members who keep on encouraging us all this time.
Next, what is differentiation? Differentiation is defined as something which is based on some other thing. In mathematics, differentiation is an expression that given the rate of change of a function to a dependent variable. Differentiation have various applications in mathematics, science, and engineering. When do we apply differentiation? Differentiation was applied when determining the increasing or decreasing of a function. It is also used when determining the speed or distance of moving object. Other than that, based on our topic, the derivative was used to find the related rates of particular function.
There are also many types in application of differentiation. One of them is related rate, which is our chosen topic to be presented. Other than that, we have analysis of function 1, analysis of function 2, apply maximum and minimum problems, and last is Rolle's theorem and mean value. What is related rate? A related rate problem is a problem that involves at least two changing quantities. The question should ask us to figure out the rate at which one is changing given sufficient information on all the others. The idea is to find the rate of change of one quantity in terms of another quantity whose rate change unknown.
Next, there is steps to solve related rates problems. First, draw a diagram if possible. Second, label all the quantities mentioned in the question. Third, find an equation that relates the quantity whose rate of change is to be found to the quantities whose rates of change are known. And fourth, use the change rule or implicit to differentiate both sides of the equation with respect to time t. And then fifth, the final one, solve for the derivative that will give the unknown rates of change. So for the question 1, a water tank has the shape of an inverted circular cone with base radius 4 meter and height 10 meter. The water flows out of the cone at a rate of 5 meters square, and then when the water is 6 meter deep, find the rate of which the water level is declining. And then here are the solution. We use the formula of the volume of the cone, which is V is equal to 1 over 3 pi r with the power of 2 h. From the question, we can get the information like written below. dV per over dt, we get negative 5, and then we are trying to find the value of dh over dt. We have the value of h, which is 6, so we just substitute it into the formula. We get 4 over 10 is equal to r per h, and then just simple mathematics, we get r is equal to 2 over 5 h, and then the value of r, we substitute it then into the formula of v, which is 1 over pi in a bracket with the power of 2 over 5h times by h, and then we differentiate, we get 4 pi h with the power of 2 over 75. And then we use the formula dh over dt is equal to dv over dt times dh over dv. We just do the simple mathematics, and finally we get the answer negative 125 over 144 pi centimeter per second.
Next, we proceed to question 2. A spheral balloon is being inflated at rate of 8 cm³ per second. Find the rate of change of the surface area when the radius is 10 cm. So for solution question number 2, we use formula volume of the sphere 4 per t pi r cube. We know that dv per dt is 8 cm and radius for the sphere is 10 cm. So now we need to know dr per dt. Using the formula, we got dv per dr equal 4 pi r square. Using chain method, dr per dt equal to dv per dt multiply dr per dv. So we got the answer 1 per 80 pi centimeter per second.
For the conclusion, we can conclude the objectives we use in this problem are accepted. So, the solution we use to find the value of related rate are success. The application of differentiation is used to compute the rate of change. The differentiation with respect to time or the other variable required application of the chain rule, since the most problem involves several variables. So, we must understand what is related rate and know that it can be used in our daily life.